Today I will be talking about the Albuquerque-Kirtland Air Force jet fuel spill and proposing to increase site and groundwater monitoring. Elaine Cimino, a hydrologist and environmental journalist, points out the jet fuel leak at Kirtland Air Force Base is one of the most massive environmental disasters in the history of New Mexico. Leaded fuel was leaked into the groundwater for nearly 40 years before being detected in 1999. The New Mexico Environment Department, or NMED, was put in charge of the situation. Since the initial detection, they have been revising and adding to their strategic plan for remediation. Currently, their goals to provide a clear vision on how to continue to advance the fuel cleanup for 2016. The strategic plan has 4 major strategies: a site monitoring and wellhead protection program, the remediation of soil and groundwater, to dissolve ethylene dibromide, or EDB, with a treatment facility, and to inform and involve the public. The NMED is currently focused on implementing interim measures to reduce or prevent the migration of hazardous constituents that have or may result in an unacceptable human or environmental exposure. To do so, the department is specifically focused on 2 areas: the source of the leak and the polluted groundwater. Of the 4 strategies developed by the NMED, I propose to focus on and increase site and groundwater monitoring as part of the wellhead protection program. I propose to increase site and groundwater monitoring for several reasons. First, it will increase critical, accurate, and informative data for project teams. It will also allow for further reduction and prevent the migration of hazardous constituents such as EDB. And it will allow us to assess human and environmental risk with greater accuracy. The first strategy to increase site and groundwater monitoring is to establish more frequent well testing. Drinking water wells will be tested every 3 weeks instead of every 4. Sentinel wells will be tested monthly rather than quarterly, and soil vapor and groundwater monitoring well tests will be scheduled monthly. The second strategy to increase site and groundwater monitoring is to extend the physical testing area. In order to better define the distribution of the plume, we will begin testing for contamination in neighboring areas, specifically the northwestern edge of the plume where it has been confirmed to be migrating away from the initial site. The third strategy is to increase the total number of wellheads for water sampling. This project will begin with the drilling and utilization of 6 new wellheads, increasing the total count from 19 to 25. Doing so will help analyze the source area and the distribution of the plume within the groundwater. Organizations actively involved in the remediation project are also involved in this proposal. These organizations include the Air Force Civil Engineer Center and their contractors, the Albuquerque-Bernalillo County Water Utility Authority, the New Mexico Environment Department, the U.S. Air Force, and the U.S. Army Corps of Engineers. On a per-well basis, the total cost is estimated to be a little over $15,000. This total includes the cost for testing ethylene dibromide in groundwater, the application fee for utilizing existing wells, the application fee for drilling without water consumption, and the average cost for installing a well, pump, and tank facility in the state of New Mexico. In summary, I propose to increase site and groundwater monitoring of the Kirtland Air Force Base jet fuel spill. Strategies involve more frequent well testing, extending the zone of testing, and increasing the number of wellheads. The benefit of this proposal is to provide better information for remediation teams in order to resolve the disastrous pollution problem. Total cost per wellhead is approximately $15,000 with the addition of time and labor. Thank you for your consideration. Additional resources and other sources can be found on this page.